Okay, so in this video we're going to be looking at simultaneous equations part 2. The first video we looked at when we could solve simultaneous equations with graphing. Now we're going to be looking at the next type of method, which is substitution. So before we look at this in more detail, just a little quick recap of why we try and solve simultaneous equations or systems of equations and what it actually means. Okay, so this was from the previous video. Let's say we have these two linear equations, okay? We know that they have an infinite number of solutions. So that means if I graph both of them, they would have different ordered pairs that would lie on both of the lines. And here's just some examples in this Venn diagram. And we were doing graphing to solve, is there a possible coordinate that works for both equations? Is there a solution that will lie on both of these lines? And that's what we looked at last lesson. This lesson we're going to look at substitution, the substitution method, and it's exactly what it says. You are substituting into an equation. And then I'm going to just graph the solutions just to prove that it is correct, okay? So we're going to check our answers. Okay, so substitution, we have looked at hopefully substitution in the past. Okay, but if you want to use this method to solve simultaneous equations, step 1, we have to make x or y the subject of one of the equations. In this example, we have y equals x plus 5 as one of the linear equations. So we've already satisfied what's been asked. Okay, we don't have to change it. One of them is already in that order. Step 2, which is going to make this a lot easier then, is we just substitute one of the equations into the other. So what I mean by this is, because I know that y equals x plus 5, I can just substitute that into the second equation. And this is what I mean. So I'm going to write 3x plus, and instead of writing y, I will write x plus 5. And I'm going to put it in a bracket just because it makes it easier for future questions. And that equals 25. So because we know what y equals in terms of an expression, I can just substitute that into the second equation. Now I can simplify and solve. So 3x plus x is 4x plus 5 equals 25. Subtract 5 from both sides, 4x equals 20. Divide both sides by 4 and we have x equals 5. So I know what my x value is that will work for both of these. So if I graph it, I would expect these two lines to intersect when x is 5, but I have to work out what y is. And all we have to do is pick one of the equations. So I'm going to pick the top one, and I'm going to substitute x in. So y equals 5 plus 5, because I worked out what x was. So that means y equals 10. And that means that is the ordered pair, or the coordinate, that satisfies both of these equations. When x is 5, y is 10. And we have just solved that simultaneous equation without actually graphing it. But we can check if it's correct by actually graphing. Okay, so let's remove all that ink. Okay, if I graph these two equations, you will notice they intersect at 5 and 10. And I didn't have to graph it. I solved that simply by using substitution. So let's move on to the next question. Okay, so again, step 1, are any of the equations in y equals something or x equals something? Well, yes, equation 1 is. So I'll label them 1 and 2. Okay, so that's done. Then step 2 then is substitute that into the second equation. So again, I know what y equals. I'm going to substitute it into here. You might want to pause the video, try it yourself. But I'm going to take the equation 2 and I'm going to substitute in 4x plus 5 equals 17. So I've just replaced the y with 4x plus 5. If I simplify, I get 6x plus 5 equals 17. Subtract 5 from both sides, 6x equals 12. And we get x equals 2. And again, just like the last question, I'm going to substitute it into one of the equations at the top. You can pick any equation. So for this one, I'm going to pick the second one. And I know that 2 times by 2, because that's what x is, plus y is 17. Well, I know 2 times 2 is 4. So if I subtract 4 from both sides, y equals 13. And that is the ordered pair. When x is 2, y is 13. That ordered pair will work for both equations. If I want to check this on a graph, that means where them two lines will intersect. So if I graph them both, it intersects at 2 and 13. Right, let's try another question then. Okay, this time we have both equations actually equal y. So we have y equals 3x subtract 2, y equals 2x subtract 5. Okay, so you might be thinking, well, what do we do now? Well, we do exactly as we've done before. We just substitute the y into one of the equations. So again, I'm going to take the first one, which is y equals 3x minus 2, and I'm going to substitute it into the second equation. I'm going to make them equal each other because they both equal the same thing. So 3x minus 2 equals 2x minus 5. Then I'm just going to solve these equations like I normally would. So subtract 2x from both sides. X minus 2 equals negative 5. And then add 2 to both sides. I will get x equals negative 3. And then again, I can substitute into any of the equations at the top. I'm going to, for this one, pick the top one. So y equals 3 times by negative 3 minus 2. Y equals negative 9 minus 2. Y equals negative 11. And that's my ordered pair. When x is negative 3, y is negative 11. So if you have two equations and they both equal either y or x, you can just make them equal each other. And then if we want to check this by graphing, you can easily see here they both intersect each other at negative 3 and negative 11. Right, let's have a look then at a different type of question. So you might want to pause it, have a go yourself, and then try and see if your answer's the same. But again, step 1 is I need to rearrange one of these to equal x or y. So this time, none of them equal one of the variables. So I need to look at equation 1 or equation 2 and decide which one would be easier, and I'm going to pick equation 1. I am going to rearrange that. Just because the y doesn't have, it's completely on its own, it has no coefficients, it is fine. Okay, so if I subtract 2x from both sides, I will make y the subject, and it will be y equals negative 2x plus 3. So instead of that first equation, I don't really need that anymore. I'm just going to use this, and I'm going to use what I have just got. Okay, so now I'm going to substitute y into that second equation. So 4x plus 4 times by negative 2x plus 3 equals 8. This was the reason why I say I put it in a bracket. It makes it a little bit easier now because I know that I have to expand that bracket. I have to do the distributive property. So 4x, then here 4 times by negative 2x is negative 8x. And then 4 times by 3 is going to be plus 12 equals 8. So that's the reason I like to put it in a bracket. It just reminds you that you have to actually multiply everything if you have a coefficient there. Now I can simplify. 4x minus 8x is negative 4x plus 12 equals 8. Minus 12 from both sides, negative 4x equals negative 4. So if I divide both sides by negative 4, I'll get x equals 1. Now if I want to find out what y is, I can substitute into any of them three equations. So the first, the second, or even the one that I have rearranged. So I'm going to put it into this one. So y equals negative 2 times 1 plus 3. So y equals negative 2 times 1 plus 3 is going to give me 1. And that would be my answer when I graph. When x is 1, y is 1. So if I graph these two equations, just to remind you, if you have to graph in standard form, you can do the x and the y-intercept. Again, that is a previous video. But if we check this answer on a graph, you can see they intersect at 1 and 1. Okay, so now we've looked at the substitution method. So the first thing, if you want to use this method, you have to make sure that you have either x is the subject or y is the subject, and then you can substitute that into the second equation that you have. If they both equal x or they both equal y, then you can make the two equations equal each other. okay? Now let's have a look at a worded question, okay? Oh, before we do that, let's just remind you of the different types of graphs. So remember, if you have two linear equations and they're not parallel, they have different slopes, different gradients, they will intersect at exactly one point. If you have two lines that are parallel, there's no solution. And if you have a line that is exactly the same, it has an infinite number of solutions. So let's look at that in a little bit more detail. So let's say, for example, I use the substitution method for no solutions. We will have 2x plus 1 equals 2x minus 2. If I subtract 2x from both sides, I'll be left with 1 equals negative 2, which we know that doesn't work. So we say it is no solution. If I take this equation at the side, if I write 2x plus 1 equals 2x plus 1, well, that is right. If I minus 2x from both sides, I'll be left with 1 equals 1, which again is fine. That means it is infinite number of solutions. Right, last one then, a worded question. So we're going to have a go at this one, but we're going to solve it by substitution. But again, there's many methods we can use. So the first thing it says, the sum of 3x and y is 8. So sum means we're going to be adding things together, 3x and y. So we're going to have 3x plus y equals 8. The second one says y is the same as 2 times x plus 3. So writing that, we have y is the same, so equals 2 times x plus 3. Okay, what is the value of x and y? Well, once you've written your equations, you should look at this and think, right, I have two different equations. They have the same variable. I'm going to use the substitution method. I'm going to substitute this one into the first one. And we'll have 3x plus 2x plus 3 equals 8. And then I can simplify. 5x plus 3 equals 8 minus 3 from both sides. 5x equals 5, well then x equals 1. And then to finish that off, we would substitute that into any of the equations. And we get y equals 5. And that is the answer for that question. When x is 1, y is 5.